Hello, welcome to the presentation of our programming project for the computer animation course. The goal was to get familiar with animation algorithms by implementing them ourselves. Right now, we can see the minimal interface we have created. It allows for game-like camera controls by using WASD and QE for vertical movement. You can click and drag on the screen to change the direction of the camera and scroll for zoom. For the visuals, we have added an appealing skybox as well as added a floor for the showcased characters to stand on. We started with animating just the skeleton, then added an option to display the mesh, which reacts to light coming roughly from the same direction as the sun in the skybox. Finally, we used linear blend skinning to attach the mesh to the skeleton by using weights provided in the FBX files, which in our case are downloaded from Adobe Mixamo. For the animation itself, we can play it, pause it, play it again, stop it. We also have added controls for getting the exact frame you want. It's also possible to type in the frame that you want and go a frame forward or backward for easier inspection. We also added the ability to loop it. As you can see, it looped around, as this is a looping animation, or if it's off, then it will just stop playing. We added abilities to turn on and off the individual displayed components, such as the mesh, the skeleton lines, or the points, if they get in the way. The last item in our GUI is a drop-down that allows for the selection of a provided FBX file. We can select a file, which is then loaded and can be played. Let's look at the comparison of our output to the preview Mixamo shows on the web. As we can see, the animations are reproduced accurately. Finally, the last option in the drop-down menu is a skinning demo, specifically coded to showcase the shortcomings of linear blend skinning. In our case, we chose the right forearm joint to show these shortcomings. First is the candy wrapper effect, in which if a joint twists past the normal point, the mesh collapses to a point and loses volume completely, such as we can see here. The second effect is pinching when a joint bends past a certain point. So in this case, we can see that the elbow joint is getting pinched past what should be the case in normal animations. So up until a point it's normal, and then it gets drawn in towards the joint. That's been it for the presentation. Thank you for your attention.